So let's also look into the review of the Hamiltonian formalism, and we will start with just the most generic discussion on how on the format of the final exam. So we will have two theory questions, one from the Lagrangian formalism, another one is from Hamiltonian formalism. The Hamiltonian formalism, as you will see below, will include also Hamilton-Jacobi equation. And we will have two problems. One is from Lagrangian formalism, and the other is from the Hamiltonian formalism. And again, so when I say Hamiltonian formalism, I do assume that it includes Hamilton-Jacobi equations and corresponding problems. All right, so the theory questions on the Lagrangian formalism we discussed in the past, and you had already midterm on those, so just review those questions. So there was altogether there was 5 questions as relate to Lagrangian formalism. They will be the same, okay, and one of them will be included on the final exam. Okay, now let's switch to the questions from the topic of the Hamiltonian formalism. So here are they. So the first one is starting from the definition of the Hamiltonian, derive the Hamilton equations. So this is how we started our lectures. Okay, so and here I don't want you to use the principle of minimal action, right? So I want to just go through a very simple procedure here to derive these Hamilton equations. So review what we had there. So second, principle of the least action in the Hamiltonian formalism. So here I want you to write the principle of minimal action in the Hamiltonian formalism, and by varying this, well, you write action in terms of P times Q dot minus H, and then you vary it with respect, you perform the variation of your action, and from that the Hamilton equations will follow. Okay. And this is what I want to do for the question 2. The question 3 is to formulate and prove a Liouville theorem of the conservation of the phase space volume. Liouville theorem of the conservation of the phase space volume. This is the most bulkiest part among all of these questions. Okay, so you please review this carefully. We discussed this in the past. Okay, so it's an interesting kind of theoretical theorem, so and it is important to have a good grip on it. Okay, so the point 4 is the revised version of the Noether theorem, but in this now in the Hamiltonian formalism. Okay, so I also want you to be able to write it, and to write all the discussions related to the Noether theorem and in the Hamiltonian formalism, to show this small canonical, infinitesimal canonical transformation, and prove how if it is a symmetry of the Hamiltonian, how the corresponding conserved quantity emerges. Okay, so I want you to do that, be able to do that as well. And the final theoretical question on this topic will be the derivation of the Hamilton-Jacobi equations. So we did it last time. I don't think it takes a lot of effort, and I expect you to be able to do this on the final exam. All right. So and altogether you will have 10 theoretical questions that you need to, be confident with to be successful on this final, and you also need to be able to solve 2 problems. One is from Lagrangian, and another is Hamiltonian formalism.